All right, for problem 3 of homework from chapter 5, this is going to be a little harder than anything you would see on an FEP test or exam question, but we'll put it in here anyway. If the outlet invert elevation is held constant, at what elevation would the contractor have to set the inlet invert elevation so that the inlet control and outlet control headwater elevations are exactly equal? So remember, we found two different headwater elevations here for inlet control and outlet control, and then we have the head that we had found for outlet control. So we're going to take a look at those two and see that the inlet control headwater is larger, so that inlet control is going to govern. And so we're going to use that information there for the inlet control to go ahead and back solve in this equation. We'll use that value for our headwater. We've got the head from outlet control. We know the tailwater from outlet control. And we can solve for that slope, which then we can back solve to find that new elevation. So wrote down some of these things already. So the inlet control is going to govern. So our headwater then we're going to use is going to be 2.4 feet. And now I'm going to go ahead and plug it into that formula where headwater equals head. So we have 3.8 feet for the head from our outlet control. We've got the tailwater depth that was given to us of 1.5 feet. And then we know we're going to go down that slope. We don't know what it is because we don't know what that elevation is going to be yet, times 200 foot length. And so let's go ahead and back solve for part of this here. We know that 3.8 plus 1.5 minus this 2.4 is going to give us 2.9 feet on this side. And then I'm going to bring that slope times 200 feet on this side. And so I know that that slope times 200 feet, if I think about my other equation here where I'm finding my slope, I used my inlet invert elevation and I subtracted my outlet invert elevation, divided them by 200 to find the slope. So let's go ahead and write that down again, except for now we're going to go ahead and find that new inlet invert elevation. So instead of putting that 112 in here, I'm going to say, so that's one equation. My second equation is going to be that x minus that 108 over 200 is going to equal that slope. Okay, so if I rearrange my variables for this second equation, I can see that I get x minus 108 is going to equal to that slope times 200 feet, which is exactly what I have here. Okay, slope times 200 feet equals 2.9. Slope times 200 feet equals x minus 108. So let's go ahead and set those two equal to each other. So 2.9 feet is equal to x minus 108. And we'll go ahead and add 108 to both sides, and we'll find that that new inlet elevation is going to be 110.9 feet. And that's what we've been solving there for that problem 3, 110.9 feet for the new inlet invert elevation.